Our last presenter for the day, Brendan Hastie. Brendan is an associate in the Water Resources Division for Rick Engineering Company. He earned his Bachelor of Science in Civil Engineering from Penn State University and is a registered civil engineer in the state of California. He has specialized in water resource engineering for the past 14 years, with experience across a wide range of water resource projects, including planning, design, and construction of structural BMPs of all types for public works and land development projects. He is a member of the Technical Advisory Committee for the County of San Diego LID Handbook and has successfully designed hundreds of low-impact development BMPs utilizing infiltration and biofiltration throughout Southern California to meet requirements for water quality and hydro modification management. Please welcome Brendan.
All right, thank you. It's good to be here. It's good to see the LID requirements are spreading throughout the state of California, and I've been busy doing a lot of LID bioretention type design down in the San Diego region for a while and done a little bit of work up here, and I know that that is certainly growing with all the post-construction requirements. So what I'm going to focus on today is the bioretention soil media specifications and a little bit on the aggregate specifications. Can you hear me? Yeah. So with that, I guess we'll get started. Everyone here probably has a good sense of what LID is. Just showing here a couple different ways you might see bioretention in the form of swales or basins. Design concepts, just different ways that we might do this. Just showing a couple graphics here in the upper left. We saw a lot on pervious pavement earlier. In terms of bioretention, the photo here in the upper right is specifically using a cistern for water storage for whatever that water quality volume you need to treat, and then dripping that out into a smaller bioretention facility. But by doing that design and storing it and dripping it out over a longer period of time, you're able to reduce the footprint of your bioretention facility. The lower left is another bioretention facility with your typical soil media layer and aggregate below there. So if you have a lot of storage volume requirements, then by extending that aggregate across the full bottom of the bioretention soil mix, you're going to get additional storage volume. Whereas the graphic on the lower right, perhaps the volume, there's not as much volume in the design requirement. So you're having a little surface volume storage, and then the bioretention soil mix layer, and then in this case, if you had a subdrain, your gravel would only be around the subdrain and not actually across the full bioretention facility. So moral to the story, there's a lot of different ways we're going to see bioretention facilities, and it's usually driven by whatever the stormwater permit or design criteria is for the local agency. So a few graphics here of bioretention facilities that have been constructed in recent years. In the upper left is a bioretention basin. This is providing water quality treatment as well as a lot of retention requirements. So what you don't see below is quite a large gravel layer providing storage volume. In the upper right, we've got a typical site here that's, instead of taking the traditional planter areas around the parking area and having 6-inch curb and the landscape being 6 inches above the parking, everything's been depressed and curb cuts to get the drainage into the bioretention area. And then the lower left, this was just a little retrofit of an existing roadway where we just lowered the landscaping adjacent, and in this case the underlying soils were very conducive to infiltration, so it was a really easy installation there, and I believe it was just a hydroseed in this case to provide the planting. And then the lower right is just another graphic here of just, you can actually design these bioretention areas into other, hardscape or other aesthetic features for the project. So permeable pavement, here's just a couple more graphics of what that looks like. You know, a lot of the issues that we see in specifications for the bioretention soil mix and the underlying aggregate come into play as well when you're dealing with pervious concrete and permeable pavers. So you want to just be aware of all those same issues. This is just another graphic of locating a bioretention swale between curb and gutter and sidewalk. You've got, this is, I guess I'll point out here, it calls out 18-inch loamy sand soil mix. So we had our, the San Diego regional permit that originally came out, and then all of the design manuals that came out and said, you know, we need to start doing bioretention. This is all it said. And so as designers, that's what we put on our plan, went out, and then what became very interesting was what contractors decided 18 inches of loamy sand soil mix might mean. We saw things come in trying to just, you know, use DG, because really, you know, the only driver here was that we needed a minimum infiltration rate of 5 inches per hour. So there were a lot of substitutions and things. There was little guidance on the actual soil mix specification, and so that's really what we're trying to highlight today is there was a follow-up effort to create that and provide more guidance. This is just one more example. This is actually all the same project. In this case, an underground tank was put below a park and then had a small pipe daylight out the side of that into basically a bioretention planter box on the right side here. So this is really getting into the meat of the construction element of it. Well, I guess design and construction. So some of the common issues and pitfalls and solutions designing and constructing bioretention. It really requires a lot of coordination between multiple disciplines. So it's not just a civil engineer doing their part or water resources engineer doing their part, but it's a lot of collaboration with the landscape architect, the geotechnical engineer. Those are all key players here in the bioretention design and construction. So what have we learned? When we first started looking for bioretention soil specs, we found that there were several out there. I think they originated probably in Washington and then Portland and then were adopted in the Bay Area and kind of made their way down the coast. And something that was really consistent with them was we saw 60 to 70% sand was the main component, and 30 to 40% compost or sandy loam. And that basically was that was in every spec that we found. Something that had been identified in Washington was that high amount of compost was leaching nutrients. There was actually a moratorium for a while to address that. And so as we started trying to develop our own set of specifications, we knew that we wanted to lower the amount of compost, but at the same time we needed enough organic matter to help sustain the plant growth and the healthy soils. So that was really the big point of discussion, getting different sets of opinions on that. Soil placement, you know, in here, a lot of the design I've done has required 5 inches per hour as a perk rate for the soil mix. And that's really important if it's more of a flow-based design where it's trying to treat the water during the storm, and if you have a subdrain system, for instance. If you're not doing a subdrain system and it's an infiltration type bioretention facility, then you don't really need 5 inches per hour. It could be 1 inch, 2 inch, that could vary. The key at that point is that you're providing enough storage volume for whatever your water quality volume design criteria is, so that you can store that, and then as long as it draws down in 24 to 48 hours, then you're okay. So compaction, that was also a key element. We saw a little bit of variability there, but a lot of specifications were looking for providing a compaction rate. And you know, civil engineers and contractors, everybody's used to, you know, what is the level of compaction when you're doing earthwork. So we saw 85% compaction, we saw 90% compaction, and that was a big question. Do we need, you know, what should it be? Or should we even be specifying a level of compaction? You know, is that important, or are there other design goals that we should be focused on? And then appropriate plant material, we just saw that in the earlier presentation. That's important to make sure that you're not just putting any type of plant in here, and then the separate irrigation system was also covered. So Rick Engineering Company, we had several projects going out for construction, and we saw several projects having issues come up. And it was that we were constantly getting RFIs on what the material needed to be, and then even when we gave input, you know, there was a lot. It was difficult to find. A lot of questions were coming up on the material, and then after things were constructed, we had surface ponding for days, and there was a lot of issues from compaction. We found that as soon as we started talking to contractors, some of them were literally parking their bulldozers in the bottom of bioretention facilities at the end of the day. So, you know, not realizing that we couldn't have compaction occurring in these facilities. So just getting the word out and opening that line of communication to avoid that is a big step towards that. But again, those are the two issues we wanted to address with some specifications. And public works projects are always going to have specifications, but we found a lot of private projects, you typically just have your plans, and so you don't have that set of specifications. And something we're doing now is we're going ahead and putting this dedicated sheet on plans to make sure that these specifications are part of the bid documents, even for private projects. So we solicited input from various geotechnical engineers, soil agronomists, and then Wallace Laboratories, which is, I believe, in LA, and they provide soil testing. We kind of collaborated amongst those outside consultants and in-house with civil engineers, landscape architects, and we started developing our own bioretention soil mix specification. At the same time that we were kind of nearing the end, we found out that the County of San Diego was actually doing a similar process because they were updating their LID handbook, and they'd seen a lot of the same issues and calls coming in. So we decided to kind of basically join efforts, figure out what they had been learning, what we had been learning, and collaboratively see if there was a way to come up with a spec that everybody was happy with. So basically what came out of that was 65% sand, 20% sandy loam, which is something that we hadn't seen in the other specifications, and then the compost has been reduced down to 15%. This is all, this is actually by volume, not by weight. And so at the end of the day, the sandy loam was added because of the arid climate. It helps bind with the compost and get water retention in there. So when you're not getting periodic, rainfall, the plants still have something to, have a water source there. So the other key component was soil placement. There's a lot of different information out there, but the key was no mechanical compaction within the bioretention facility, and that goes for whether you're going to have a subdrain or not. And then as far as installing the soil mix layer, 6-inch to 12-inch lifts, and then lightly watering those was what we ultimately came up with. So key items to note, and at the end, we've provided that it's actually a 6-page specification, and Darla was going to put that on the LIDI website and make that available. But just some key items to note that you'll find in the specification. I mentioned the mix, but the end goal of that was to reduce the amount of organic matter to about 5% by weight. So while there's 15% compost in the volume before you mix, at the end of the day, you're going to have around 5% organic matter. And that's enough to sustain the plant growth, but not so much that you're going to have a lot of leaching of nutrients. So delivery, storage, and mixing. I mean, this can be done on-site or off-site. The key is to not have it mixed in with native soils. Placement methods, I touched on that, doing the lifts and natural compaction with light watering. So erosion and sediment control, we heard, I think every speaker here today has touched on that because of that is really important. So, having your proper SWIP measures and all your temporary BMPs in place during construction to protect these bioretention facilities and not opening them up until the end, until the site is fully stabilized. Surface stabilization, so this kind of depends on what type of plant palette the landscape architect is looking for, but unless you're doing some type of hydroseed, a layer of mulch is often recommended, and then the type of mulch is important. So you're looking for a mulch that's not going to float. So there's a lot of guidance coming out on that type of mulch. And then the bottom bullet here, this was kind of a lesson learned from one of our projects. The landscape architect had basically covered the entire bioretention facility with cobble. There were still plants dispersed throughout, but it was pretty much all cobble. And this was one of the projects that had a compaction issue. So to go back after the fact and try to till the soil was really difficult with all of the cobble. So they actually had to take the cobble out, till the soil to uncompact it, and then put the cobble back in. So, I think putting cobble in bioretention facilities is good. It's a good aesthetic thing, but, if it's a 50-50 balance, it will help with maintenance or compaction issues that might come up. The plant palette, I won't touch on that. You just heard about that. And then irrigation, you also heard about. Basically, it should have, if you are going to have irrigation, make sure it's got its own zone. Its needs are going to be different than the rest of the plant palette. Maintenance, we've had a lot of questions come up on that. All stormwater BMPs are going to require maintenance. What's good about bioretention facilities is most of the maintenance is just your typical routine landscape maintenance, trash removal, pruning the vegetation, visual inspections to make sure that it's still infiltrating. A common recommendation is every year or two to go in and reinstall a couple inches of mulch, and that will help with the long-term functionality of it and preventing the underlying soils from clogging as much. And we may see more and more stormwater maintenance agreements required to give assurances to the public agencies that the individual owners are going to be maintaining these. So that was quite a bit on the bioretention soil mix specification. That's really been the main issue. But a lot of questions do come up on the aggregate specifications. So, one way to go is there's a Class 2 permeable material, and Caltrans has their own specification for that. And if you use that, the gradation's small enough that you can place the bioretention soil mix directly on top of the gravel layer. And so you don't need the filter fabric, which isn't recommended, and you don't need a choking course. Another option, option 2, which is actually the graphic here, this shows if you want to use a different type of gravel underneath, maybe the Class 2 permeable material is hard to get or too expensive, you can go to another alternative that's washed so you don't have fines, but then you'll need a choking course, a couple inches of choking stone and a washed sand to help make that transition from the soil mix to the larger gravel below. So I'm just going to wrap up here with a couple project slides. This is a Scripps Proton Therapy Center, so this was the example with a lot of cobble. You'll notice that the overflow drain is purposely set up from the bottom so that we're getting surface ponding. And then this project, if you're interested in knowing more about it, the County of San Diego's LID handbook that just came out in June of this year that has a full set of specifications. It also is a good resource for plant palettes, just so you can see what they're doing elsewhere. But they took this project and kind of walked through all the steps on the design, lessons learned, and what came out of that. So you can see how the This was more of a design side. I was breaking up all the different drainage areas to each bioretention facility. Another project here, this is a streetscape project. The top right photo shows bioretention bulb outs, so I think that's becoming a little bit more popular. So you'll see the curb cuts and all of the streetscape. This is actually in a what's going to ultimately be a very urban environment, very wide parkway that's all sidewalk and buildings up to the right-of-way and wide streets. So basically all of the street, all of the sidewalk are going to these bioretention bulb outs, and it helps provide with the traffic calming and separation of the parking lanes as well in the streetscape. And then where you didn't have parallel parking, a linear facility was installed in this location. So due to the urban density and the large buildings, this is where you ended up with vertical cutoff walls. So a little more expensive, and if you've got a little more space and right-of-way, then you can avoid the cutoff walls like this and actually have your natural side slopes. So and this was just one other project, a couple photos of bioretention facilities highlighted in the upper left and the bottom right here. This was a project that had to retrofit. The site had basically designed everything and built all their impervious area without their stormwater control measures or their BMPs. So it was coming in after the fact and adding curb cuts and getting the drainage into the and creating bioretention areas, but getting the drainage into them was a bit of a challenge. And Camp Pendleton, there was a photo of this earlier, so this is a pretty large bioretention basin. I like this just because I think the landscape architect did a really good job making this blend in with the overall aesthetics. So looks pretty good, and it's very functional. A lot of storage volume. This requirement was actually a 95th percentile storm event because it was on the federal property. They have their own LID manual that requires that. And that concludes the presentation.